In today's video, we will be talking about converging lenses and how you draw a ray diagram for a converging lens. The other thing that you'll be able to do after watching today's lesson is be able to determine the image and object relationship for converging lenses. And what I mean by that is the image being produced virtual or real? Is it inverted or upright? Is it magnified or is it shrunk? Okay, and those are all questions that can actually be answered by just actually drawing a ray diagram. Now, I won't get into any of the math involved in it, like in terms of the actual distance or the actual height of the object, but we can objectively say, you know, it's a bigger or smaller object. Okay, so let's get right into the fun. For drawing ray diagrams of a converging lens, I'm going to give you 4 steps, kind of like how we did with mirrors. Okay, so there's 4 steps to drawing a ray diagram. You're going to pick a point on top of the object and draw 3 incident rays traveling towards the lens. Okay? And again, typically in almost all of our problems, I really can't think of a problem that wouldn't be this way, you're going to see an arrow as the object. So I always pick the top of the arrow, okay, as my starting point, and then I draw 3 incident rays traveling towards the lens. Once these incident rays strike the lens, refract them according to the 3 rules of refraction for a converging lens. And that was talked about in a previous lesson. So if you need to check that out just to refresh your memory on what those 3 rules are, you may want to do that because those are important. But I'll go through them when I do some examples shortly. Once you've drawn those 3 refracted rays, mark the image or the image of the top of the object, and then you can repeat the process for the bottom of the object. But quite frankly, in most of our problems, it's probably almost unnecessary to do that, because once you have the top of the object, you can just draw the arrow in. It'd be different if I was saying, you know, like draw a person or say some odd shape like a car or something like that. Well, we won't do anything like that where you're drawing ray diagrams of a car. So typically it's pretty easy, or simple objects like an arrow. Okay? So let's do a little practice here, and again, this will give you an idea on the 3 rules of drawing refracted rays from a lens. And let me just pick an exciting pen color. Let's go with, green sounds like fun, but you don't, okay, there it is. It's blind. All right, so again, just kind of a quick refresher. This line I'm drawing is called the principal axis, and then a converging lens is a lens that is fatter in the middle and thinner towards the top. Okay, and here is my focal point of my lens there. And remember, lenses have 2 focal points, so there's one on the left and one on the right. Okay, and I'm trying my best to make them equal distance from the lens because they should be, but again, I don't have a ruler and I'm not like making this exact. Okay, so let's draw my object. Here it is in all its glory, this arrow. Okay. So for my rays, I'm going to switch to a different color. Let's see here. Let's do yellow. Okay, so you want to draw 3 rays. Okay, the first one, I'm going to pick the top of the arrow. That's my starting point right here. The first one is parallel to the principal axis. Okay, so that should be a straight line as best as you can. And again, a ruler is what you need to use, and a pencil, because you typically will need to erase multiple times. But yeah, if you don't use a ruler, you don't get real exact answers, and that can be a problem. So I highly recommend investing in a ruler. So here is this incident ray. It hits the lens, and the rule is that this line, once it refracts through the lens, is going to go through the focal point on this side. So I'm going to try my best to draw a straight line that goes through this focal point, looking something like that, and then draw an arrowhead on there. There it is. Okay, so that's one. All right, my second incident ray is going to go through this focal point, hit the lens. Okay, so I'm going to go through the focal point and then hit the lens. And again, I'm going to try my best to draw a straight line to actually go through the focal point. That's pretty close. Bam, it hits the lens. Once it hits the lens, it starts going parallel to the principal axis. Okay, and I'm kind of going off the page here, but it goes parallel to the principal axis. Okay, so that's 2. The third incident ray is probably almost the easiest one. You pick the top of the arrow, and then you're just going to go straight through the center of the lens and just keep going. You're just going to draw a straight line through the center of the lens, and it just keeps going. Okay? So clearly you can see these lines are not very straight, and that is a problem because they all should be intersecting at one point, and where that point is where my image would form. I'm going to change pen colors here real quickly just so we can show you where the image would be. And so the image would be somewhere over here. Again, it's really tough for me to do without like a ruler and straight lines and all that stuff. But wherever all three of these yellow lines intersect, that would be where the image formed. And again, I apologize. I don't know what's going on with this one right here. It looks really like it should drop down more. I must not have done something right with drawing it straight. But that is basically it. That you need to draw 3 incident rays that strike the lens and then they refract according to the 3 rules I just discussed. And we're going to do a few more practice problems, so don't worry, and hopefully I can make it look a little better than this one. But this is an example of drawing a ray diagram for a converging lens. Okay. So one of the things that you may notice is that what happens to the image produced if the object is less than 1 focal length. Okay, what do I mean by that? Well, let's do it in example. And I'm kind of giving away the excitement here. I'm telling you a virtual image will be formed. Okay, so sorry if you were looking forward to something exciting happening. A virtual image will form. So here's my lens. Okay, and I'm going to put my focal point kind of far away. Put it here. And let's see, about equal distance, be maybe about there. Okay, so there's my 2 focal points. Right? Let's make my object. And we'll try to pick a different color here. My object, it says, is going to be less than 1 focal length. So it's going to be between the lens and F. Okay, what happens? What kind of image is produced? Okay, well, let me change pen colors here for drawing my rays. Now, the same rules apply for this as they did in the previous slide. It's just I'm going to get a different type of image produced. Okay, so I'm going to start again from the top of my arrow, which is right there. And I'm going to draw a line that's parallel to the principal axis, and it hits the lens. Okay, and the first rule is that once it hits the lens, it's going to refract in such a way that this light ray is going to go through this focal point way over here. All right, so I'm going to try my best. That wasn't so good. To draw a straight line, and it should be going through this focal point right there. Okay, so if you can use your imagination, it goes through that focal point right there. So that's one. The second one says that it is supposed to go through the focal point on this side and then hit the lens and then go parallel to the principal axis. Okay, now you'll notice that's really hard to do. How do I draw an incident ray that goes through this focal point and then hits the lens? Well, what you end up doing is you take your ruler and you line up the focal point, which is right there, with the top of the arrow, and I'd personally draw a dotted line kind of indicating that a light ray would be going along this direction, and the dotted line indicates it's not really a real light ray, it's kind of our imagination, if you will. And I'm going to extend that line until it hits the lens, and then I can make it go parallel to the principal axis, straight across parallel to the principal axis. Okay, so again, dotted line from this focal point until it hits the tip of the arrow. Then you can draw a real line because now you can kind of see that's an incident ray of light hitting the lens, and then it refracts, that's parallel to the principal axis. Okay, so that's 2. The third one is it goes right from the top and it shoots straight through the middle of this lens and it just keeps on going. Okay, now one thing you'll notice right away is these 3 refracted rays of light over here are never going to intersect. So it's like, well, what the heck, man? Where is my image going to be produced, right? And the answer is no image will form over here. But what I can do is I can what's called trace back these rays that refracted off of the lens and see where they intersect. Okay, and so if I do that, this ray is parallel to the principal axis, so it will refract back this direction. And this one it's at an angle, right? It's angled towards the focal point, even though it's a really crappy line. It's angled towards the focal point, and so it will refract back that way. And this one will refract, or if I trace it back, I should say, I should stop saying refract. Trace it back, it'll go this way. And you'll notice there's a point where these three lines kind of intersect, and let me just change pen colors one more time to yellow, where these guys intersect, and it would be like right here. And that is where the image would be produced. And this is called a virtual image because it's on the same side as the object is on. And you'll notice the virtual image is actually larger than the object. Okay, so it's been magnified. Okay, so no image was produced over here, which would be called a real image, which was my example in the previous slide, but a virtual image was produced over here, basically because the object was less than one focal length from the lens. Okay, so that's kind of a rule that we can hang our hat on. Okay, if it's less than one focal length from the lens, a virtual image will be produced, and it's actually going to almost always be magnified. Okay. So what happens if the object is directly at the focal point? Okay, well, again, I kind of give away the excitement. No image is produced. Okay, and again, I'll show you why. So if I were to set up a drawing here, and here is my converging lens, and then I'm just going to put my focal point as a dot, just so that things don't get confusing here. And let me just change pen colors real quickly to something else. We'll go with white. So here is my object, okay, right there. Now, I should put another focal point over here. Sorry about that. So here's my object, okay? And according to my rules, I can't even draw, or my backup. According to my rules, I'm going to first draw a line that is parallel to the principal axis. And then it's going, once it hits the lens, it's going to refract in such a way that it goes through this focal point. And again, I'll try my best to make that as straight as possible, but it is what it is. Okay, so that's rule one. Rule two is that you draw, or an incident ray of light hits or goes through this focal point on the left-hand side. Well, if the image is right, or I'm sorry, the object is right at the focal point, you can't draw any type of incident ray of light. So that one doesn't work. But what we can do is we can do the third rule, which says I can draw a ray going from the top of the arrow through the middle of the lens and just keep on going. Okay, and you'll notice these two rays of light right here are what's called parallel, and they will never intersect. So no image will ever be produced on this side. Okay, well, what about if we trace it back, kind of like in the previous slide? What if we trace back these rays of light? Okay, so let's trace this one back, and I'll start doing dotted lines, and it starts heading this direction. And I trace this one back, and it starts heading this direction. And if I can even put an arrow on them if I want. You'll notice these guys are also parallel. Even though they don't look like it, they are also parallel, and they will never intersect. And so, believe it or not, no image is ever produced if the object is directly at the focal point. So just kind of have that in writing, in words for you guys. We basically went through three examples. If an object is located beyond the focal length, a real image will form. And that was my first example that I did in this lesson. The second example I did was I made a virtual image, which a virtual image is formed if the object is located less than one focal length from the converging lens. Okay? And then the third example I did was if the object is at the focal point, no image will ever be formed. Okay? So that takes care of today's video. I will see you guys next time.